My name is Jacek. I am Android developer for the past 5 years, and about 1 year ago I started a blockchain project, bought some bitcoins because this was actually about the time that Bitcoin rose to like 50k for one Bitcoin, and this actually splurged the different ideas and blocked our news feeds about blockchain, crypto, and so on. I will not be talking about in depth about blockchain or crypto technologies. There are much more knowledgeable people about this, but I will give you a rundown of ideas and how to actually approach applications that are written with the blockchain in mind. So, like I said, I actually about well over a year ago for the previous company, I started an Ethereum project with the smart contracts. It actually started around time that I had some downtime. We had no projects actually for me. So I picked up the Ethereum, looked around the ideas around this, and set up the private blockchain and saw what I can actually see, what we can do. And this is how the GitHub for Ether came up. We actually wanted to do an internal project, and this was a project by developers for developers. We didn't want to actually work with the mobile application and blockchain together because this was actually quite hard. I don't know if there are clear solutions and plug-and-play solutions like right now. So we came up with this simple idea. We will use what we do every day. So what we do every day, we submit pull requests or merge requests. If you work with GitLab, you do code review, you submit some changes, and for that you would get Ether on a private blockchain, on our blockchain. And then you would have profit, right? That would be quite virtual profit, but the idea was actually not to run it on the main blockchain, on main Ethereum. And this is when you actually search about the idea of blockchain and running code on blockchain. This is possible, especially if you actually follow the news. You know there are smart contracts and they are supposedly solution along with blockchain. What you first find out is smart contracts or smart contract, and this is a part of the whole picture what I will be talking about today, because when you think about applications for blockchain, it's usually a distributed application or so-called DApp, which has usually 3 parts. What people usually mention is smart contracts. Not very often there is Oracle, and there is some front-end. Front-end can be anything. So, front-end. We actually didn't want a web app because there were 3 of us, and we didn't actually want to spin up the whole web application, but it actually came up. And we built a front-end with Node.js. Michał Karpiuk actually wrote it. And we had the initial idea. All the blockchain information for the contracts that are made for each pull request would be displayed via comments. But that was not enough, so we built a web app. We would display active contracts. We would allow adding users to the blockchain. This was a private blockchain, so creating a wallet to which you would get your crypto was also problematic, so we automated that. We wanted this completely transparent. Display the wallets so we can actually compare to each other how our work actually improves or so on. And that would be the last point. This is actually running on a separate machine, and this is actually to drive point home that the DApp, distributed application, this is actually multiple applications running on different hardware, and they come up and create the whole application. There are multiple parts of it. The second part is the Oracle, something that people usually don't mention, and what we would understand, this is a presenter or controller in a way. Our actually Oracle would talk to JSON RPC. JSON RPC is API that is for us to use to actually talk to blockchain. We would talk to GitHub because that was our VCS. And we would put some business logic. Why exactly here and not in smart contract? Because smart contracts are supposedly like code run on blockchain, and this supposedly is super secure. The problem is that you shouldn't actually put much logic into it. Why? Later on. Running, and this is running on separate machine too, so we would have the front, which could be anything web app or a mobile application, the Oracle, which is kind of a backend when you think about it, but for us it would work in a DApp context. This is presenter or controller, and we have smart contracts, and this is the third part. And if you think about it, and if you think about architecture, you already know where this is going. The smart contracts in our context, we would create contract for the pull request, so we would store the reviewers, and how much it was actually worth, and during it we would adjust the price that we would pay out to people that were part of the contracts. We would also store repository contracts, which were info about each repository and each project, and that was a mistake. Why? Later on too. And this was running on Ethereum virtual machine. And this is actually not running on one machine, but multiple machines that we do not have control over. And this is an important part to actually understand. So, as I said, you already know where this is going. So I want to actually show you the general approach, how to actually see the DApp and so on. So we have smart contracts, which is kind of a model which informs actually our business logic that would trigger different actions, and front, which is a view. So when you think about it, this is actually quite similar. You can actually approach the DApp with the MVP or MVC on whatever architecture you want. You can actually apply it and think about in this context with it. And okay, forgive me for the butchered UML, but this is a simple graph of how it actually was structured. So we had a GitHub at the top, which we would talk via their API and webhooks. The front-end part, which would display our things, we would have the Oracle, which we try to approach with the clean architecture in mind, repositories, use cases, and so on. It is possible. We wrote it actually in JavaScript. That was quite new to us. Many people actually hate JavaScript. It was fine, I guess. And there is the blockchain part, which would have repositories, smart contracts, and so on, and different info stored onto it. So the DApp itself is like multiple architectures, and if you break it down, like the whole DApp is running on multiple machines with multiple architectures. So the DApp, you can approach it as MVP, MVC, MVI, whatever you are actually more familiar with. The front end can be anything too. The Oracle can be also anything too. MVI, MVC. This doesn't matter. You can actually structure it as you want. But smart contracts are beasts of themselves. So they run in EVM. This is technology provided by Ethereum blockchain. You can set up your own EVM and run smart contracts via this. And this is triggered via transaction. And transaction is very basic part of blockchain. Each thing you run smart contract. So you run a smart contract, a function of smart contract, you trigger a smart contract, you transfer funds, all this is a transaction. Transaction is an important part of it. Because each transaction actually costs to deploy and run. So we have the Ether, the basic currency that we pay for everything, for our transfer, cash, and so on. And it actually costs, hold on, because I got lost. So everything actually costs. And the point, another, when you actually research the subject of blockchain, what people will usually tell you, this is instantaneous and it happens automatically and it is super secure. And this is kind of a white lie. It may, but usually may not. We didn't have that much of a problem with it because we had the private blockchain. So we actually controlled all over this. But this may be a problem. Why later on also. And smart contracts are not we try to also do like clean architecture with smart contracts. So like and solid. So one contract would be responsible for one thing. You can actually do it, but the cost increases with running, deploying, and so on, and migrating all of this. And smart contracts, you should actually think with design by contract. This is different idea. I will talk about it later on, and I will show you some code actually how to achieve it. Design by contract was implemented at some level by different languages that we are not that familiar with, I think. I think actually you could tell us about it, but whatever. To run actually contract, we would need to actually write it and so on, but we would need to actually connect via JSON RPC. So there is some similarity. I will show you what to a node with an API exposed and submit a transaction. So this kind of looks like a the REST API or SOAP or whatever. Could think about it in this context. And running contracts, or rather not. The problem with blockchain is, especially with the main blockchain, with the private, this is not a problem. So transaction needs to be actually selected. There's pool of transactions submitted for each new block of blockchain, and this needs to actually be selected. It needs to be verified by each of the nodes that's selected. And actually, you need to get a callback with success. And I don't mean like 200 with the REST API, and it doesn't actually fail. But with this actually goes the event portion of the blockchain itself. To drive point home, when you can actually think about the communicating with blockchain, you can actually proxy it to REST API somehow, to a point. This is the wrong order, but looking at the bottom, we have the basic like REST API connection. You have some REST service, right? It connects to a server, and maybe there's a load balancer, and it will split the connection to the other servers, other instances, and we have the response immediately. With the blockchain, or rather the DApp application, we would have in the Oracle, we would have a Web3 service. Web3 is a library that you would use to connect to the blockchain and JSON RPC. You connect to the node with API exposed, the JSON RPC, and this on behalf of you submits a transaction with running the smart contracts. And then other nodes in the whole blockchain would select it, hopefully, verify it, and hopefully it has enough actually verifications and it goes into the block. And then and only then I think you will have the emit of the event that you would look for, because actually submitting the transaction itself is not enough. But design by contract. I actually searched this idea, and you have design by contract, and you can go to Wikipedia and read about it. But the basic idea is on the next slide. But if you want to actually think about smart contracts, you should think about legal state machines. And there are companies that are serving the private resolutions with blockchain, and they actually think and push the idea that people that should actually work with smart contracts, should have also background, should be cross-platform in a way. They should have the engineering background and the background in law. And designed by contract, this is thinking legal state machine. We have something like this that you people with B2B actually work. So you have preconditions, you assume that this should work like this. You have software components that produces errors, and there are post-conditions when you get cash. This is not that much, but designed by contract, you also always need to fulfill the conditions to actually run the code. And then and only then you would go into another state. So you are in one state if you fulfill all the like permissions and requirements, and only then you run some contract like transfer of funds and so on, and then you would actually transfer the funds unless you fail actually fast and revert. And all of this is provided via Solidity. And there are three scary words if you search about it. It's inspired by C++, Python. I have no idea why Python. I've done like 2 projects with Python, and JavaScript, which you usually actually quite scared of. I kind of understand it. But Solidity is the language to write the Ethereum smart contracts. It has a pragma which defines our feature set, which you can actually proxy onto like Kotlin version and so on. But this is kind of tied to the EVM we are running in, so version of blockchain, and blockchain actually has its own versions. And that pragma is important because it changes quite rapidly. The Kotlin evolution or language evolution even now is not as fast as it was for us during like half a year or maybe closer, like shorter. Pragma actually increased by quite a few versions, and quite a few things changed. And there are modifiers. Modifiers are quite a new thing, and are a great help into into clarifying actually code and driving home the idea of design by contract. And you have also events, which helps you with asynchronicity. The asynchronicity is actually squared in the context of blockchain because you also submit a transaction on another thread. This runs at some point in time at different machines, and it may finish at completely different part of time. So about some meat. So this is actually a piece of code from Solidity by example. This is example that the creators want you to follow along. You have the uint. You usually have type at the beginning. You have the address, type, and state, and so on. We have enums, the standard things with the language. When you define contract, you of course don't use the class, but contract, and with this, you will have quite a few built-in functions that you will see. And there are events. Events are something that you actually inform the world, like Oracle, about that something actually happened, because Oracle will listen for the events. Oracle would send asynchronously the transaction, and then will listen that actually something happened on the blockchain, and it will register it. Onto the constructor. Constructor. Nothing that much special, but this is a purchase. So we actually want to sell something to someone, and we would register the seller and the value that we want to actually sell it for. And there are modifiers. Modifiers are actually quite cool part about Solidity, because you can actually check all the preconditions. So we actually don't want to like run a function. If you are not a buyer, only a seller can trigger certain actually functions within the smart contract, or the buyer, or whatever it is. We need to actually check if this is in a specific state. Also, this is a part to actually use. The underscore and the, what is it? Semicolon. This actually is a fun part too, because this would indicate that rest of the function of the code that actually runs stuff is represented by this. So, function itself. The definition, it is what it is. We have actually the function, the name of it, the visibility, and then actually we would attach the modifiers that would actually check if we are in a correct state and so on. And there's also the modifier that is payable. So the buyer, if he wants to actually confirm a purchase, he needs to actually send a transaction with certain value. Not only the value that we are reading from the message. Message is a built-in object of the contract itself, or rather transaction that is sent. And he needs to actually send the value that we want to buy it for, and also submit some gas, which is ether in a way. And only then we actually we proceed with locking the purchase for him. There's also the second function where actually needs to be triggered by the seller. He actually confirms it, and this is another pattern of design by contract and solidity and smart contracts overall that you should actually, creators actually push towards, because you should not automatically assume that something is in a current state. We should not actually push funds, because that was actually historically this was the issue with security of certain contracts. So useful patterns with solidity. When you think about it and you want to actually write a contract, you should explicitly demand, confirm, pull to receive. So if you want to actually send some funds or send some crypto, you should actually demand that someone pulls for it. So if there is crypto locked for someone, he needs to actually trigger a function. You should actually fail fast and revert. Revert is a built-in function in the contract, and if you need to actually remember each time you run a function, it costs. So you actually need to submit funds to actually run it, and people will not be very happy if it actually fails. So you would fail fast if the conditions are not met, and revert, which would send rest of the gas that is available, was not burned, for the transaction to running it back to the sender. Don't comment and describe the contract design. This is an important part of it, because we actually didn't comment in the code, but rather used GWT method. So given, when, then, which ties into design by contract, we would in the header of the contract actually describe each part of the contract like it would actually be a paper contract, which is part of the idea itself that you want a legal background to. And don't completely trust Web3. For you Android developers, that you know actually the REST and you use retrofit. I don't know what it is on iOS, but Web3 is a library to actually connect to the JSON RPC and talk to it. The problem with Web3 is they actually have two different versions. There's old version, which we were using, and in old version they just decided not to support. One pattern was not actually completely taken into account, and they actually decided that they will not be fixing it in the previous version, and you should actually use completely newer version, which changes quite a lot and would cost you quite a lot to actually re-implement. And Web3 has had at least quite a few issues with this. It would skip params or would just fail, and so on. And going about the end, the cost. So the skills that you would need, like Geth and Solidity and that's solidity is required. Geth is a thing that you would actually spun up your own private blockchain. Geth itself is knowledge of itself. You don't need actual like deep down knowledge of blockchain, but you actually need to know this tool. You need Solidity, JavaScript, and Node. That's at least what we have used. You need to actually Docker. At least it was important in our part. So you actually close up all of the nodes of these distributed applications, and quite a lot of bash. That actually was on my part because we automated quite a lot of things. We wanted to scrap the whole blockchain altogether and set it up completely again. And I actually invested quite some time into writing some bash scripts to actually speed up building of the blockchain itself, setting up the Docker and so on. And with FTEs, we actually had 3 Android devs by the second month, I think. I actually took 2 colleagues of mine and we started working on it. We had a half FTE of project manager at some point because it actually spun up to the point that you had 3 components that we need to actually wrangle somehow, and this is a new knowledge and so on. And we had actually assigned half of QA, which we needed to bring up to speed and also explain quite a lot of few things. This is the cost. This doesn't have to actually be for you. You can actually write all of these parts alone, but will take a bit longer. But this was on our end, and this was, I think, about 3 to 5 months. So this was our cost, at least, on a mobile developers that were actually learning quite a few new things. And I think that's done. If you want me to actually go into other parts of the system or how to actually approach it, I could do another one at Q&A, I guess.
What was the result of the project? Have you shipped it?
Huh?
Have you shipped it?
Yeah. You can ship anything, technically. What was the result? Our knowledge, I think. And that was actually, I think, the best outcome for us, at least, because we learned quite a few new things and quite a few new technologies. Yes.
What about real-life applications? Would you see any?
Blockchain is interesting, right? It's a cool technology, but thinking like mobile dev, this is too slow for the mobile user. You are pissed off if the phone is slow for 1 second, and blockchain can take from 2.5 minutes to 10 minutes to 1 hour to actually complete a transaction. So if you can solve the issue of immediate satisfaction from actually submitting, doing anything on blockchain, or take control of the security, or take advantage of security of blockchain, which there is some, then yeah. But on mobile side, right now, not much.
So are there any libraries for mobile for Android to actually interact with the smart contracts directly without using the server? Like, running the node on the phone, very like small node.
Right now, there should be more, I think. I know there was a library, but the problem with the blockchain and this tech overall, you have the JSON RPC, and as long as you can connect to the node that will serve this API, and you will talk with the phone over JSON RPC, you can actually do it, I think. There were some libraries like a year ago, but they were like just open source projects.
Nothing is supported out of the box, right?
No. And that's the case with most blockchains right now. It's mostly ICOs, at least it was. Anything that at that point was workable was Ethereum, which was with a pragma 0.2 if you saw in the sample, which is well below 1.0.
Okay, maybe I will put some light on this.
Please do.
Because I did some mobile development with Ethereum, and because all you need is the access to the node. You can use some public available nodes like Infura and communicate with it using JSON RPC. So all you need basically on the mobile side is just an HTTP client. And if you want to have something more than pure HTTP calls to Infura server,
what you're saying, you basically don't own the coin because you have to trust the node that you're connecting to, right?
But it is always the case.
I mean, if you have a very simple node on your phone, you have to be
okay. There are some lightweight implementation of the nodes, but I'm not sure if they are mature enough to trust them.
That's why I was
Okay. I know that one of the company which manufacture of the phones.
Yeah, Samsung is like the wallet.
Yeah. So, but I don't know any details about that. And I also have one question for you. Do you know if there is an option to extract a message from the transaction which failed?
No idea. It was like 1 year ago, so memory would be hazy too. But so transaction that actually fails, and you want to the message itself?
Because you can, like you showed on the slides, you can have some preconditions, which when they are not met, will fail with following message.
Yeah.
But actually, as far as I know, there is no way to get this error message from the failure.
Kind of in a way, because the framework that you would use to write the smart contracts would be Truffle, and Truffle at some point supposedly was to support debugging the code itself. I don't know how mature it was. I know that by the end of the project, actually a colleague of mine that was on the project mentioned it, but he actually didn't succeed in using it. So that's a problem in itself. So you could kind of debug it, but other than itself, sorry.
Okay, so thank you, Jacek.